Hello everyone. For class 8, we'll continue with the chapter light, and today we'll discuss about the spherical mirrors. Okay. So in the previous classes we learned about how light is refracted in a prism, the dispersion of light, the formation of rainbow, spectrum. Today we'll discuss about spherical mirrors. Now what do you mean by spherical mirrors? So a spherical mirror is a curved mirror formed by a part of hollow glass sphere with a reflecting surface. So it's a curved mirror, okay? It's a curved mirror in which one side is silver and one side is reflecting surface. That means light can pass through the reflecting surface. So when light comes, it hits that reflecting surface. So there are two types of spherical mirrors. One is concave mirror, the other is convex mirror. Now concave mirror is a curved mirror with the reflecting surface on the hollow side. So this is your concave mirror. See, this outer part is your silvered surface. You know what silvered surface means, painted silver? And this inner part is your reflecting surface. That means a ray of light comes and hits this, strikes on the inner side. Convex mirror is also a curved mirror with the reflecting surface on the outer side. So for a convex mirror, the silver surface is inside. That means the inner part is silver and the outer part is your reflecting surface. Like, you know, you have seen the spoon, isn't it? You all have seen spoon? Everyone uses spoon at home. So you know the curved part. You've seen this curved part, isn't it? The outside part acts as a convex mirror. The inside part acts as a concave mirror. You can check it for yourself also. Look at the spoon yourself and you see the kind of images in which which is formed in concave will be inside, and the kind of images which is for convex will be outside. So the difference between concave and convex is concave has silvered surface outside and reflecting surface inside. Convex has silvered surface inside and reflecting surface outside. Okay, so this is concave mirror and this is convex mirror, and together they are called spherical mirror. So there are two types of spherical mirrors as we discussed, concave and convex. So convex has reflecting surface outside and concave has reflecting surface inside. Now, see, this is the line which is drawn like this. This shows the silvered part. The black line which is drawn like this is your silvered part, and the blue line shows your reflecting surface. Now there are certain terms which are important over here. Okay. First, you know, concave and convex both are a part of spherical mirror. So it's a part of spherical mirror. So if you draw a dotted line, it forms a sphere. Both the mirror forms a sphere. And the center of that sphere is called center of curvature. So what is center of curvature? Center of curvature is the center of the sphere of which the mirror is a part. Okay. Center of curvature is the center of the sphere of which the mirror is a part. So the center is called, the C represents center of curvature. The center of the mirror is called pole, P-O-L-E, pole. Okay, the center of the mirror is called pole. This is true for both concave and convex. And when you draw a straight line passing through center of curvature and pole, okay, this straight line, this black line, straight line which passes through the center of curvature and the pole is called principal axis. The straight line which passes through the center of curvature and the pole is called principal axis. Okay, and curvature and the pole, this distance, the distance between the center of curvature and this pole is called radius of curvature. From here, center of curvature till here, okay, this distance from C to P is called radius of curvature, represented by capital R. Here in this case, this is your center of curvature, this is your pole. Okay, the distance between C and P, that is called radius of curvature. So these are the important terms that you need to know for a spherical mirror. First, center of curvature, which is the center of the sphere of which the mirror is a part. Next, pole is the center of the mirror, center of the concave or convex mirror. The center of the mirror is called pole. If the straight line which passes through the center of curvature and the pole is called principal axis, and the distance between the center of curvature and the pole is called radius of curvature. So these four important terms, these are the four important terms that you need to remember. Okay, center of curvature, pole, radius of curvature, and principal axis. Now there is one more term which is called focus. Okay, and why did I not show you focus there? Because focus, when we define focus for a concave and convex mirror, it becomes slightly different. Okay, that's why I did not use that slide. Now focus is defined as the point in which the ray of light might meet or appears to meet. Now this is very important. In which the ray of light actually meets or appears to meet. Now see here. This is for concave mirror. Okay, concave mirror. What happens is the ray of light when it strikes the mirror, okay, when the ray of light which is parallel to each other, when they strike on the concave, when they strike on the reflecting surface of the concave mirror, this reflected ray, the rays which are reflected after striking the reflecting surface, they meet at a point. That means all the reflected rays, they actually meet. You know how real image was formed, isn't it? So they actually meet at a point, and that point is called focus. So in case of concave mirror, the reflected rays, they actually meet. After reflection, the ray of light, they meet at a point, they converge at a point. That point is called focus. This is for concave mirror. Whereas for convex mirror, what happens is, see, this is what convex mirror would look like. So ray of light, okay, the ray of light, after striking the reflecting surface, they will not meet, they are moving away. See, they are moving away. Okay, the reflected ray, they move away. Now they meet only when they are produced backwards. So the dotted lines here, what does it show? That the ray of light, the reflected rays meet only when they are produced backwards. Which means, in case of convex mirror, the reflected rays, they do not meet, but they appear to meet. Okay, they appear to meet when produced backwards. When this reflected rays, they are produced backwards, the dotted lines, so they are produced backwards, they appear to meet at a point. And this is your focus in case of convex mirror. So the difference between focus in concave and difference between focus in convex is, in concave, the reflected rays meet at a point. Okay, the reflected rays, they actually meet at a point. That is your focus. Whereas in convex, the reflected rays, they do not meet. Okay, the reflected rays, they do not meet, but meet when they are produced backwards. That means they appear to meet when they are produced backwards. And that is how, so this is why we define focus is defined as the point in which the ray of light, as your reflected rays, meets or appears to meet. Okay, so in case of concave mirror, they actually meet, and in case of convex mirror, they do not meet, but meet when they are produced backwards. Now another term, as we discussed about focus, there is another term. Okay, that is called focal length. What is focal length? Focal length is the distance between focus and the pole. The focal length is the distance from the lens or the focal point. This is the distance from a lens or mirror at which the parallel rays will meet. So what is your focal length? Focal length means the distance between focus and pole. Okay, radius of curvature is the distance between center of curvature and pole. And focal length is the distance between focus and pole. Please know the difference. Radius of curvature means C and P, the distance between C and P. And focal length means the distance between F and P. That is focus and pole. And there is a relationship between focal length and radius of curvature. So the relation is focal length is always half of radius of curvature. Focal length is half of radius of curvature. So if radius of curvature is 20, what will be the focal length? 10. Because 10 is the half of 20. If the radius of curvature is 30, what will be the focal length? So what's the half of 30? 15. So the focal length will be 15. Okay, if the radius of curvature is 15, what will be the focal length? So half of 15, that is 7.5. So hope you understood this. So focal length is always the half of radius of curvature. Okay, so with this we'll complete till here, and we'll continue with some numericals, and we'll continue with the chapter how the image is formed in a concave mirror, how different images are formed in a convex mirror. Okay, till then, have a good day and have a good time. Thank you.